Hi, I'm Caroline Chanel, and I'm going to present the work of Giorgio Angelotti, our ANITI PhD student that works on automated human-robot interaction model learning and planning. This thesis aims to propose a formal framework to control the interaction between human and robot in order to enhance the performance of the team. The principal idea is to drive the interaction not only in function of the recognized skills of each agent, but also in function of their current capabilities. This falls in a new mixed initiative interaction paradigm that implies the availability of monitoring systems and the design of decisional systems to assign tasks to both agents in function of their current states. A first difficulty is to define a relevant and formal interaction model and then learn its parameters. This learning phase is difficult because we dispose of a limited batch of experience. So here we address the problem of offline learning for planning. A second difficulty is to compute a robust policy for this learned model, knowing that there is a distributional shift between the real and the learned model. Concerning the learning of a Markov decision process, what one may know is that the model result of a learning phase is strongly dependent on the policy used to acquire data and on how well the human operator interacts with the system. We note that the policy used in the acquisition phase is not optimal in terms of gains, and that the operator was not necessarily performing well. That said, we need to investigate a formal methodology to define state, action, and observation spaces. We need to learn how to observe the human operator state, and we need to learn the transition function of the human-robot system. In parallel, it could be interesting to use expert knowledge and density estimation techniques to detect potential symmetries in model dynamics. If such property is detected, the batch of experiences can be augmented. This idea was investigated by Giorgio during his international mobility in Pompeu Fabra University in Barcelona with Professor Hector Geffner. Let's now suppose that such interaction model could be approached. The next step is to compute a robust policy for this model. The idea is to search for a risk-sensitive policy. Here, we talk about the risk of applying a policy that, when maximize an average gain, may achieve poor results when applied to the real system. So, based on Bayesian MDPs literature, we search for policies that maximize the average gain of the lower quantile of the distribution over the possible models. A first approach was proposed by Giorgio in a specific case of offline risk-sensitive Bayesian MDPs. This work was submitted to NeurIPS. Finally, we hope to evaluate those different developments in the firefighter robot game scenario, where a human operator may cooperate with a robot to extinguish a maximum of fires. In this scenario, the human operator works on several tasks in parallel, what possibly generate degraded cognitive states. In this case, it is interesting to choose which tasks should be done by the robot to favor a better performance of the operator and consequently a better performance of the team. Thanks for your attention.